There are mainly three questions you have to ask when you choose EC2 instance type, and almost no one is asking that. And because of that, they are choosing the wrong EC2 instance. They are overpaying or underperforming that applications. In this video, you're going to learn EC2 instance families. So mainly three families we are going to discuss, which is commonly used. Apart from that, there are other three families, but I will show you on the documentation itself. But the number one is C, compute optimized instance family, R, memory optimized instance family, and ID, storage optimized instance family. Have you ever rented a cloud instance or EC2 instance and paid double what you needed to? And this happens very often. That team chose the wrong EC2 instance type, and at the end they overpaid for the job. In this video, you're going to learn what EC2 instance families actually are. We're going to talk about three key EC2 instance families and compute versus memory versus storage, the real differences you will understand in this video. And number three, we're going to discuss real world workloads for each family. And we will end with exam trap questions. When you choose a wrong tool, it's a real pain. Using the wrong EC2 instance family, it's like choosing a wrong tool for your job. But when you choose a right tool, it is a breeze. It is everything working that time. So choosing right instance family is actually the right tool you're using for your job. When you do that, your application runs fast, you pay less, and your user is happy. So there are mainly three specialist workers you have. Number one is a compute optimized. This is a fast thinker, more CPU, less waiting, and built for calculations heavy tasks. The EC2 instance types are C7i, C6i, those kinds. Though it starts with C, and 7 is a generation, and 6 also is a generation. I is an Intel processor. Then second specialist is a memory optimized. This gives you great memory, remembers more data at once, built for RAM heavy workloads such as database. Instance type starts with R7i. The third specialist is ID, storage optimized. It is like a filing cabinet experts. This is a blazing fast disk IO built for read-write intensive applications. So there are two letters involved, I and D. I is for when storage is designed for higher IOPS, input output systems. So it doesn't take care about the throughput. But D is for storage is designed for the throughput, especially when you use for the streaming the data. Let's talk about one families at a time. C, the first thinker. Compute optimized instances packed in more CPU power relative to memory. Okay, the real world example is gaming servers, scientific simulations, video processing and encoding, ML inferences. These kind of jobs, compute optimized instance is perfect for them. And then second specialist is the R, memory optimized instances. R for RAM. If you want to do in-memory databases, caching layers, real-time analysis, then SAP applications. So memory optimized instance will be the right fit for this kind of job. The third specialist is the storage optimized instances. So these instances actually are built for extremely fast read and write of the data, delivering high IOPS input output operations for per second via local NVMe SSD. The I series excels in the IOPS, and D series offers massive sequential throughput, especially if you want to stream video or audio media from the computer. If you want to do big data workloads, NoSQL databases, log processing system, and data warehousing, you should go for the storage optimized instances, which starts with I or D. And in the storage optimized instances, you have to see whether your application is streaming data or whether your application needs more IOPS, such as it's accessing the database, such as Oracle database. Let's talk about some real world use cases for C compute optimized instances. The video processing requires enormous computations to encode content at multiple resolutions simultaneously. The solution is compute optimized instances, handle encoding and processing pipelines efficiently, maximize CPU utilization and minimizes wait time. The R RAM optimized instances. The problem you may solve: core banking databases performance degrade under peak transaction volume. Queries get slow. This is a problem you may face, and then solution would be memory optimized instances. Keep more of the working datasets in the memory itself so that it can access fast in low latency. For the storage optimized instances, the problem you may solve, such as millions of logs and transactions, need rapid storage access, especially during the seasonal peak. The solution is storage optimized instances deliver the high performance local NVMe storage needed to ingest and query data at a massive scale. So these are the real world use cases for each instance family: compute, memory, and the storage. AWS Exam loves to test these instance family. Example: a company runs a large in-memory database requiring extremely low latency. Which EC2 instance family should be selected? Most of the students select compute because they think speed synonymous to the compute. But right answer is RAM optimized instances or memory optimized instances, because the core requirement is about keeping data in RAM for a low latency access, not about raw CPU throughput. The golden rule is CPU heavy is a compute, RAM heavy is a memory, and disk heavy is a storage. This is for your quick references. C for CPU performance, R for RAM capacity, ID for disk speed, and IOPS. Remember these 5 things before you end this video. Number 1 is EC2 instance. There is no universal best instances. The right choices always depends on what your application actually need. Number 2, remember, choose C family instances when your bottleneck is raw processing power, simultaneous simulations, encoding, and inferences. Choose R family instances when your application keeps large dataset in memory for ultra fast access. Choose ID family instances when your application need massive IOPS or sequential disk throughput. Last but not the least, read scenario descriptions carefully in your exam. The right answer is always embedded in the workload details itself. So quick recap: the performance depends on the right sized instances, eliminate bottlenecks, and let your application run at the theoretical maximum. The cost: you stop paying for the resources you don't need, no more over provisioning out of the uncertainty. And for the exam, definitely workload matching questions appear on your every AWS exam. This knowledge is directly testable. Whenever you see a workload, ask yourself one question: does it need more CPU, more memory, or faster storage? You ask these 3 questions. Most of the students or professionals, they don't ask. So if you ask, automatically it comes to your mind what kind of EC2 instance family you should go for. So let me know in the comment what kind of EC2 instance family you're going to use for your database. C for the compute, R for the memory, and ID for the storage instance family. Before you go, I want to show you in the browser how you can navigate to the EC2 instance family. You go to Google and search AWS EC2 instance type. When you search it, so there are 2 links mainly it comes. The top one is the EC2 instance type. This is the one you're going to use, and then second one is EC2 instance types, but this is a documentation, right? So I'm going to click this one, and this one, if you go down, you see the instance categorize. So this defines what kind of EC2 instance family you're going to explore: general purpose, compute optimized, memory optimized, accelerated computing, storage optimized, and HPC optimized. So you already learned about compute optimized, memory optimized, and storage optimized. These are the three commonly used. But apart from that, you can also leverage general purpose instances, families, and accelerated computing, HPC, high performance computing instances, right? So you click on any of these and explore on your own time, right? And pick the right EC2 instance family for your project. I hope this helps you to understand what the EC2 instance families are and what are the real world use cases and how do you pick the right EC2 instance family. Thank you so much. I will see you in the next piece.